Hi everyone, in this video, we're learning how to find a basis for the solution set of a homogeneous system of linear equations. So what is homogeneous? It means that this is equal, so it means that your constants here equals to 0. So everything will add up to 0. So you have a2 all the way to etc. to am. This will be your coefficients, a1, b, all this and this one. So you will have altogether m number of rows and here you have n number of columns. So if you have n columns, that means you have x1, you have 3 columns, that means you have x1 plus x2 plus x3. And if you have like 2 rows, so it's a1 and a2. 5 rows, a1, a2, a3, a4, a5. And for b also, it's all the same. So now we have based on our system of linear equation, we can abbreviate the same thing with an augmented matrix. So a1, b1 and all these are your coefficients of matrix. So it's all here, a, then b, etc. and everything. And our matrix of constant is 0 over here, the right hand side. So let's say, for example, I have a matrix of a1 x1 plus b1 x2 plus c1 x3 equals to 0. And the second row, I'll have a2 x1 plus b2 x2 plus c2 x3 equals to 0. So in this case, I have 3 columns. Why? Because x1, x2, x3. So 3 columns, and here 2 rows because a1 and a2, b1, b2, c1, c2. Therefore, I can write in this form a1, a2, b1, b2, c1, c2, and now the matrix of constants 0, 0. So now it's clearer. Let's continue. We will reduce it to reduced row echelon form. And now we identify the leading and non-leading entries. That means which is also known as the variables in that sense, because the variables will correspond to the column with the non-leading entries. And hence we write the leading variables in terms of the non-leading variables. So now we can, by doing that, we need to write it in terms of any parameter. So like in this case, we have our variables are x1, x2 and all the way. So parameters, we can use it as, for example, z, w, etc. So like for here, these are the examples of the parameters here. So now we can write a description of the solution sets by grouping all the coefficients of the individual parameters together. That means our parameters, it means x1. So this is all our variables, and then the parameters are here separately. That means initially you get x1 equals to c1 y1 plus d1 all the way to yl. Depends on how many column vectors you have. If you have like two column vectors, you have two column vectors here. Therefore is y1 and y2. If you have three column vectors, you have three column vectors. It's also you add y3. So it depends on how many column vectors you get in a basis will determine the value of how many y you get. So if three column vectors, y1, y2, and y3. So now we have an example here to start with. So, but before we continue, hence we can write our basis as, in this sense, our basis can be written as, so from here is C1 Cn all the way to what 1, that means your any value, so these are your bases we will express based on this and this, but you have all the way to here. So let's give an example here for here. So now we can do step 1. So now step 1, an augmented matrix. So hence 1 minus 4, 3, 0, 2 minus 8, 6 will give me 0. So now these are my matrix here, the left hand side here, matrix of coefficients and the matrix of constant. So now step 2, reduce it to row echelon form. You are in now step 2 phase. Well, this is row 1, row 2. Let's make it to row echelon form first. So what do? We add minus 2 times of row 1 add to row 2, because you want to eliminate the entry below 1 in this first column first. So let's see how it goes. Let's keep our first row constant, 1 minus 4, 3, 0. So now minus 2 times 1 equals to minus 2, minus 2 plus 2 equals to 0. The same for this, minus 2 times minus 4 equals to 8, 8 minus 8 equals to 0. And here also the third column, minus 2 times 3 equals to minus 6, minus 6 plus 6 equals to 0. And for this, it will go to 0, because 0 plus 0 is 0. So now, step 2, step 1, done. Step 2, done. Now, step 3, what's the leading variable? So now, our leading variable is 1. So this will be our non-leading variable. So now What's the leading one? So our leading variable is in the first column. So the first column corresponds to x1. So leading is x1. And non-leading is x2 and x3. Now let me tidy this up first. Then we can have more space to write. So now step 4. We write the non-leading variables in terms of any parameter. So let x2 equals to w, x3 equals to z. So now let's express x1 in terms of these two. So x1 minus 4 x2, so it's minus 4w plus 3x3, so it's plus 3z equals to 0. Therefore, x1 equals to 4w minus 3z. So now, step 4 done. Step 5. Okay, step 5, let's clear this and we write on top here. Sorry, there's not enough space. So sorry about this. Okay, let's clear this part here. So step 5. So therefore, x1, x2, x3 equals to, so my x1 is 4w minus 3z. Let's write the whole thing first. 4w minus 3z, x2 equals to w, x3 equals to z. Therefore, we can simplify this further. x1, x2, x3, let's group all the coefficients of the individual parameters together. That means equals to, let's do W first, so it's 4, 1, 0, W plus, so the Z for the first row is minus 3, Z coefficient is minus 3, so it's minus 3. For here, there's no coefficient of Z in the second row, so it's 0. And for the third row, the coefficient of Z is 1, so it's 1 Z. So step 5 done. Now the final step, we can write our basis in this form. So from here, let's conclude that therefore basis equals to 4, 1, 0, comma, minus 3, 0, 1. So this is a 2 vector set. So this is our basis. We are done. So this is done. So we have already learned how to find the solution set initially, and now based on this we can find the basis. So we have come to the end of this lesson. If you have any comments about my videos, please feel free to drop me a comment and I'll get back to you. So thanks so much for watching. Have a nice day.